Exercise 5E, graphing logarithmic functions. Today we are going to be learning about graphing the log function. In order to be able to do that, what you need to do is find the x and y intercepts of log graphs, find the vertical asymptotes of a log graphs, and then apply any transformations, and finally be able to sketch it on a Cartesian plane. So let's go ahead and start looking at what a logarithmic function looks like. In basic term, this is what the logarithmic function looks like. We have a vertical asymptote, and it's going to be at x is equal to h. In this specific case, it's at x is equal to 0. And if this were just our basic graph, then this point here would be 1 and 0. This may look quite familiar to you because, as we've discussed, logs and exponentials are opposites, or the formal term is inverses of each other. So if we kind of think about what an exponential graph looks like, first of all, it has an asymptote at y is equal to 0, and it'll look like this. And then our log graph, this time we have the opposite. The asymptote is at x is equal to 0, and it'll go off like this. And what you'll notice is that it is reflected in the line y equals x. So that's our line y equals x, and there's our reflection there. So you can see that these are opposites to each other. Usually we have our intercept at 0, 1. So of course for our log, we're going to have it at 1, 0. So that's what a log function is in basic terms. Our equation is, as always, with our transformations, h is left and right, k is up and down, and then we can have any dilation factor that's out the front. What happens if we change the base of our logarithm? Well, if you remember with exponential, the higher that the base is, the faster or steeper that it grew. So if this was, this could be 2 to the power of x, then 10 to the power of x might look like this. So it's steeper. So once again, it's the opposite in this case. The steeper or larger that the base is, the slower that it's going to grow. So you can see here, our 10 grows slower compared to 2. So it's always about the opposites. On the right here, we have some common features. So the graphs all cross at the x-axis at 1 and 0. Because of this formula here, log a of 1 is equal to 0. Remember, if we were to take that base over, a to the power of 0 is always equal to 1. So it doesn't matter what the base is, anything to the power of 0 is equal to 1. We will have a vertical asymptote at the y-axis, x is equal to 0. Of course, these are without any transformations. The domain is r positive, so that's everything after 0, not including 0, but the range is r. So that's from negative infinity to infinity, again, opposites. All of these are increasing functions, and it can be seen that the smaller the value of a, the steeper of the graph is going to rapidly rise, which is the complete opposite to exponentials. So that's all the information that you need. Let's go ahead and start sketching. So example 14, sketch the graph of each of the following, showing any axis intercepts and the asymptotes, and then we need to make sure we state the domain and the range in each case. So I'm just going to label these. So 1, sketch, and 2, state, just so that I can remember to do that. So what we have here is a logarithmic graph. We need to figure out exactly what's happened. First of all, the whole graph has shifted 1 to the right. Why is this important? Well, it affects my asymptote. So my asymptote is now going to be equal to 1, x equals 1. And finally, the whole graph has shifted 3 upwards, but that doesn't really change too much in terms of what it looks like. Just like with exponentials, if the graph moved up and down, that mattered because the asymptote changed. But if it moved left and right, it didn't really look very different. So that's all of our key information. We can already start sketching it without even finding the intercepts, but we will do that in a little bit. But this one should be very easy to sketch. So that's x is equal to 1, and then the whole graph has moved up by 3. So it's just going to be my standard log. Again, it doesn't really make much of a difference. If I were to move this up, it's still got this shape. So it doesn't really matter about the moving upwards. How it does affect moving upwards is, of course, going to be my x-intercept. So in order to find my x-intercept, I'm going to make y equal to 0. So 0 is equal to log e x minus 1 plus 3. I'm going to take the 3 over, and then we utilize our swappy rule in order to get rid of that log. So that's where I take the base over here. And then I can get x by itself by adding over to that side. And I'm just going to write it as 1 on e cubed, just to make it nice and pretty. So that's what my x-intercept is going to be. And of course, there's no y-intercept, so you don't have to find that. So that's step 1 there. That's me sketching the graph. I'm now going to state the domain and the range. So the domain, for the domain, x is going to be an element of everything from 1 to infinity, and for the range, or y is going to be an element of r. And that's it. Next one. Now we need to sketch log e x plus 2 minus 1. It's actually going to be very similar to the one that we just did, so if you'd like, pause the video and give this one a shot. Here I can see the whole graph has moved 2 to the left, which means my asymptote is going to be at x is negative 2, and also the graph has moved 1 downwards actually, which doesn't really have any kind of overall effect. So we can start to sketch this. Now, where this does have an effect is that this log graph could either go like this or it could go like this. And because we don't know exactly where it's going to sit, we need to find our intercepts before we go ahead and draw it. It is going to have both an x and a y-intercept. So we can start with our x-intercept. We'll make y equal to 0. So we'll do our swap rule, we'll take that over, and that will be x plus 2. So that means x will be e minus 2. Now that value there, we need to know that e is around 2.7, and so 2.7 minus 2 is still going to be a positive number. So in fact, this is going to be over here. So our graph should go like this, and just to confirm, we'll go ahead and find our y-intercept as well. Not that that really helped us because it's a little bit tricky to know what log e2 minus 1, so we're just going to have to rely on the fact that this is a positive number. So once we have that, we can go ahead and draw our log in. It'll look something like that. So that will be e minus 2 and 0, and this will be 0 and log e2 minus 1. And that's how you complete that function. So the domain x is an element of negative 2 to infinity, and the range y is an element of r. So usually for log graphs, it's going to be an element of r unless we actually restrict it, then that'll be a different scenario. Okay, so back to this question here. So what do we have? This, first of all, this negative out the front means that we're going to have a reflection in the x-axis. So usually my graph is going to go like this, and when I reflect it in the x, it's going to now flip, so it'll look like that. The next thing is that our whole graph has shifted over to the right by 1. That's really important because that means my x asymptote is going to be at 1. So it's going to look like this. And I don't really need to find my intercept because that's just going to be 1 plus another 1. Because there's no actual dilation that's occurred here. My normal x-intercept is at 1, and then I've moved it 1 over. But just so that we can make sure that that is correct, we can go ahead and find our intercept. So we're going to make y equal to 0. I'm going to divide both sides by negative. And then I'm going to take the e over. So that'll be e to the power of 0, x minus 1. E to the power of 0 is just 1. And then when I take 1 over, that'll become 2. So as predicted, this x-intercept is going to be at 2. What we can now do is find the domain and the range. So the domain, the smallest x value I can see is 1, so infinity. And then the range is just going to be r once again. Next one, y equals 2 log e minus x plus 2. So we've got a few things that's going on here. First of all, the negative that's in front of the x is going to be a reflection in the y-axis. So normally my graph goes like this. Now it's going to reflect in the y-axis, so it's going to look like that. And I just tried to draw a little graph for myself just so I know which direction it's going to go in. We've got a dilation of factor 2 from the x-axis. It's not really going to do much from the x-axis, and we're going to move upwards by 2. Again, that doesn't really do much. So because there's nothing that's happened here in terms of horizontal, my asymptote is just going to remain at 0. So my graph is going to look like this. Now, in terms of my intercept, because there is a dilation, it's not going to be as simple as just being -1 as it would if it were just a reflection. So we're going to make y equal to 0. 0 equals 2 log e negative x plus 2. I'm going to take the 2 over, and then I'm going to divide by 2 as well. So that'll be -1. And then I can use my swappy rule to bring the e over. That'll equal -x, and then of course I can just divide by x. So by -1. So then that'll be negative, and 1 on e is the nice way to write it. We don't have a y-intercept in this case. Finally, to find the domain and range, so the domain, the smallest x value I can see is -infinity to 0, or another way we can write that is r negative. And then for the range, that's just r. And of course we can write x as an element of and y as an element of. Next graph, y equals 2 minus log e 1 minus x. There's again a few different transformations that are occurring here. The first thing is you should always make sure that you write, if there's anything in front of the x, you need to factorize that out so that you can see the true translation in terms of what's happened. All right, so we've got a reflection in the x and the y-axis because both negatives are existing here. That's in the x-axis and that's in the y-axis. So usually my graph is like this, then I'm going to reflect in the x, and then I'm going to reflect in the y. So it's going to look like this. Then I have a shift to the right by 1. That's going to affect my x asymptote, which is now going to be at 1. And then I'm also going to move up by 2, but that doesn't really do much overall. So that's all my key information. I can go ahead and sketch. I've got an asymptote at x is equal to 1. That's not very dotted. Let me try that again. And it's going to look like this hook. Now, again, we come onto the situation where I don't know if it's going to go like this or like this. So this time I have to find my intercepts before I go ahead and sketch. First, I'll start with my y-intercept. So I'll make x equal to 0. That's just 1 minus 0, which will just be 1. Log e1 is equal to 0 because e to the power of what will give me 1? Well, that'll only be 0. So that's 2 minus 0, which means y is 2. So because of that, it's going to cross in the positive region, so I know it's going to look something like this. So my x-intercept must be negative. Let's go ahead and find that x-intercept, make y equal to 0. I didn't really leave myself too much space there. Let's try and put it there. So that'll be 0, 2 minus log e, 1 minus x. I'm going to take the log over to make it positive. And then I'm going to use my swappy rule. So take the base over, that's e squared is equal to 1 minus x. And then I can take the x over and the e squared over. So that means x is equal to 1 minus e squared. And that will be a negative number. And up there I'll label, that's just 0 and 2. And there's my fully sketched graph. Domain, smallest value is -infinity to 1. X is an element of, and range is once again r. Say the transformations of f of x needed to form the graph of f of x is equal to this. So what would f of x be? So that's just our basic function, log ex, and we want to go to this function here. So that's 2 log e x minus 3 plus 1. So it's very similar to what we've just been doing before. So when we go ahead to sketch, we've been being able to recognize all the transformations. That's exactly what's happening here. Remember, when we're reading transformations straight off of a graph, we want to go in the order dilations, reflections, translations. So first of all, we're going to have a dilation of factor 2. That's the 2 out the front from the x-axis. And then we're going to go through our translations. So that's 1, 2, 3. So then we're going to have a translation of 3 units in the positive direction of the x-axis. And then 3, we've got translation of 1 unit in the positive direction of the y-axis. And that's it. That's the end of exercise 5E.